classical mechanics. Our chapter is kinematics of particle motion. Now, first we talk about classical mechanics. It is the study of motion of physical bodies at the macroscopic level. When we study the motion of bodies at macroscopic level, then it is deal by classical mechanics. Now, classical mechanics is governed by some laws, which we said Newton's laws of motions, which are responsible to tell about the motion of a body. Now it is reformulated in different forms such as Lagrange, the Hamilton, and the Hamilton-Jacobi formalisms. And there are two branches of classical mechanics mainly. Number one is kinematics. Now, kinematics is the study of motion of a body without knowing its cause. And second branch is dynamics. It is also the study of motion of a body. What we in this case also want to know and what is cause of the motion. This is covered by dynamics. Now, motion is connected with time and space. The body has mass and extent, but when we consider a motion of a particle, then we neglect its dimensions. Now we talk about vectors. Vectors tell about the position of a particle in a space, and it is written as, let's we have a vector A. It can be written as vector A is equal to AX EX cap plus AY EY cap plus AZ EZ cap. Here E cap is a unit vector and used to describe the direction of a vector, and it is equal to the vector over its magnitude. And in a space XYZ coordinate system, we can draw a vector in a such a way which is indicated by picture. Now we are able to about the idea of a vectors. They basically grasp about the position of a point in a space. Now let's talk about frames of reference. In description of motion of a body, it is better to specify its position in space as function of time. For this purpose, we used some reference frames with respect to which motion is described. Now, a vector A function of time is equal to its component ax function of time a cap x plus ay function of time ay cap plus az function of time az cap. Now, what is inertial frame of reference? There are frame of reference relative to which all bodies that do not interact with other bodies move uniformly in a straight line. Such frame which satisfy this condition is called inertial frame of reference. The laws of classical mechanics remain same in all inertial frames of reference, but they are different in non-inertial frame. And non-inertial frame is a frame which has acceleration.